Hi, I'm Peter Burris, analyst at Wikibon. Welcome to another Wikibon theCUBE digital community event. This one's sponsored by Juniper Networks. Like all of our digital community events, this one will feature about 25 minutes of video followed by a crowd chat, which will be your opportunity to ask your questions, share your experiences, and push forward the community's thinking on important issues facing business today. So please wait until after the video to join your peers in this important crowd chat. A few weeks ago, I had an opportunity to interview Bikash Koley, Chief Technical Officer of tech leader Juniper Networks. To counter myths in data center design, Bikash discussed his truths based on his extensive experience designing, building, and running some of the world's most advanced data center and cloud infrastructures. Hi, I'm Peter Burris, and welcome to another CUBE conversation from our wonderful studios in Palo Alto, California. And we got a great CUBE conversation, one I've been looking forward to for quite some time. With me is Bikash Koley, who is the CTO of Juniper Networks. Bikash, welcome to theCUBE.
Thank you very much, Peter. Really excited to be here.
Well, the reason I'm excited about it, Bikash, because you've been at the vanguard of thinking about the role of cloud in business for quite some time. Why? Where have you come from?
Yeah, so I have been the CTO of Juniper Networks for exactly about a year now. Spent a decade before that at Google. I used to operate Google's production network, and boy, it has been a journey.
I'm sure.
I joined Google the year after Google acquired YouTube, when it was a tiny little video service company. Search was growing, and the way I describe my experience at Google is I saw necessity is the mother of invention, like in front of me, because a lot of what we had to build there, we had to build out of necessity, because we're scaling at a pace or scaling to an extent globally that hasn't happened before. And if you really think of what was the core of that scaling, it was almost always data. Whether it was indexing the whole internet, which was growing, it was doubling every year at the time, or whether it was this little video service called YouTube, which was growing at a crazy pace. The core to it was, how do you manage this volume of data, both ingestion, processing, and distribution? And the core to that was always network. And the interesting part was, a lot of the technologies that are used for really both consuming and distributing data today did not exist in those days.
Well, from the outside, one of the things that's fascinating by Google is it always looked like what it was doing with technology made sense. And so it might have been, a degree of chaos and emergence, which is kind of what the necessity of invention kind of ends up looking like.
Yes.
But your contributions to open source, your diffusion of knowledge about what you were doing was so advanced and so different that it became kind of the beacon, kind of the lighthouse for thinking what the future of cloud was.
Yes.
Now I'm going to make an assertion here, and here's my assertion, that in many respects cloud really is the programming model for networks.
Yes.
Would you agree with that? And then I'm going to ask you about how you're going to transfer all this knowledge into Juniper to help other customers. So starting with that notion, is cloud really the programming model for networks?
It actually is the programming model for any data and application network is a key part of that. I have another description that I've used often is, there are three characteristics that if you meet in an infrastructure that is around either IT or applications, then I call it a cloud. It is ubiquitous, it is reliable, and it is fungible, right? And if you think about it, it's the same three characteristics that you find in all the utilities that you rely on day in and day out. You find that in electric grid, you find that in water. I have a term for it, I call it invisible infrastructure.
Well, hold on, when you say fungible then, just to make sure,
yes,
you're saying that it's fungible in the sense that the service that you're paying, the service that you're using is the service that you're paying for.
That is correct.
Okay.
And you can get to use the resource for the service that you need and not pre-build everything on day one, right? Very similar to what we do with electricity.
Ubiquitous, resilient, fungible.
That's correct. Now, if you look at how you get ubiquity, resiliency, and fungibility, you'll find that it's network that gives you all of that. Ubiquitous because you have a global network. It's fungible because you build these fabrics, whether it's inside of data center or connecting your data centers, that allows you to move resource as they're necessary, right?
And track your utilization
And
of
track your
resource.
utilization and give you security, right? And reliable, because every time you build a data center or every time you build an edge connectivity, you are ultimately giving people or applications multiple ways to access where they're going, right? So network is absolutely key to how something becomes cloud. And I mention that because, cloud is almost always used as a term for public cloud. I actually believe, like you said, cloud is a programming model, cloud is an application consumption model, and it's not just about public cloud. It is absolutely applicable to infrastructure that you build on-prem, as long as you're meeting those criteria.
So we like to say that the notion that you're going to move all your data to the cloud, which is kind of the popular concept,
Yes.
is not necessarily, I don't want to say it's wrong, but it's not right.
Yes.
That the real way of thinking about it is you're going to move the cloud to where your data is located, and data has very real characteristics, latency, cost to move it, et cetera. So if we start from that proposition, it suggests that it's not like all the networking problems are going to be suddenly the public cloud providers' issues. Every enterprise still has to conceive of how they're going to define their network, because they've got installed machines that aren't going to go away anytime soon. They've got new applications that they want to build on data that must remain private,
Yep.
or has local attributes that have to be instantiated. So it means that the notion of networking inside the enterprise remains important. How are you going to help Juniper take that knowledge that you've gained about building great cloud networks and bring it into an enterprise so that they can take advantage of everything that they need to take advantage of with their networks?
Yeah, Peter, you're exactly correct, is that cloud is going to follow data, because ultimately data has gravity, and it's gravity in the form of the cost of moving it, whether the law of the land allows you to move it, whether the physics of it, the latency that you need to the data allows you to be away from where your users are. And there's some things that don't change. Your users are where they are. They're not necessarily going to come.
And those users are not necessarily people.
And they're not necessarily
going to be
people.
devices and other types of
Absolutely.
things that
Absolutely.
must be where they are, because they're performing an act that must be performed right there.
Water meter readers are in water meters, and utility pole readers are in utility poles, right? So they need to be where they are. So you're absolutely correct, is that cloud has to come to the data, not the other way around. And network has a huge role to play. Going back to what lessons I learned, and I'm bringing with me to Juniper, but more importantly to networking for the cloud era. First of all, every infrastructure has a context and it solves a certain problem. So it is a mistake to try and solve every problem the same way. So one of the questions that I get asked all the time as I talk to the CIOs of the Fortune 500 companies is, I'm not that interested in what my peer is building. Tell me how I build a Google or an Amazon or a Microsoft-like infrastructure. And my answer to them always is, it's a question of what problem you're solving. Mm-hmm. Now, when they say, I want to build a Google or a Microsoft or an Amazon-like infrastructure, I believe they're actually asking for a few properties, not necessarily building it the same way. You actually can't build it the same way, because it's always people, process, technology, and more than likely an enterprise doesn't have the same software engineers or the same operations folks that a Google or a Microsoft or an Amazon or others like that Facebook they have, right? So what are the properties? The properties actually are very applicable to enterprise. First of all, when you're building for scale, you cannot treat your infrastructure as pet. You cannot go and configure every single element individually. You have to treat it as cattle. So when you are building a network, you are building the network, not the elements in the network, right? And that is the concept of what is now called software-defined networking, right? Where intent-driven software model drives what your network does. You cannot scale it out in any other way. Mm-hmm. Two, when you're building for scale, things will fail, because that's the law of probability. If you have 10 times more switches, you're going to have 10 times more number of failures. It's the nature of the beast, right? What makes your system reliable is the software, because the software understands when failure is happening, and it does something about that without waiting for a human to go and react, right? So you must have software or automation that allows you to scale in that way. Third, you really cannot start separating between what is physical networking and what is virtual networking. Because if you think of the world that we're going into, as you pointed out, most enterprises have lots of legacy infrastructure, not because they love it, but because their business relies on it, right? You still have things that run on bare metal. It's not that you tomorrow decide I'm going to run everything on serverless on Amazon and I'm able to do it. You can't, even though you might want to, right? So it is important to build an infrastructure that respects the legacy and allows you to still build automation and software abstraction.
But it's even more than respects legacy, that allows you to generate new options on the value of that legacy.
Absolutely.
So that legacy can sustain and increase in value
Yes.
as you add new elements. Have I got that right?
Absolutely correct. It is where, if we use an example, you might actually have a database that runs on a traditional NAS or a database server. You might be building applications that are running on public cloud that needs to access that database because you have all of your customer data there, right? So the key here is build an infrastructure where that sets of bare metal servers that might be connecting to a switch or a firewall gets to talk to a public cloud endpoint that might be running virtual network, right? And that's the power in my mind of overlay and really combining overlay and underlay together. These are the ways that public cloud infrastructures have been built. If you look inside an Amazon or a Google or a Microsoft or a Facebook, you will see these qualities, right? Where virtual and physical have been blended. Software is used for operation, including automation. Reliability is the key driver as to why you put software. And let's not forget the importance of having operators that are comfortable with operating a software stack, not so much a collection of switches and routers, right? Those are really the learning that I believe are very applicable for any enterprise that are building, or any service provider that are building large infrastructure.
That suggests that ultimately the business has to look at the primary citizen of the network differently.
Yes.
The primary citizen used to be the server or the device or the switch, whatever else, the router. We have to move beyond that as these are the assets we're trying to take care of, and start thinking in terms of where the data is. So the concept that I like to use with clients is this notion of building networks of data.
Yes.
And having a software-defined infrastructure that's capable of configuring those networks rapidly, where the asset that we're worried about is the data and not the switches. Would you agree with that?
I would completely agree with you, and the keyword, Peter, that you mentioned is rapidly. The need of the day is, the days of having more or less static network is gone. And what I mean by that is, yes, every network is in some ways dynamic. It does stuff in there.
Sure.
But in most networks, the endpoints have been static. You have this many servers, you have this many POPs, you have this many data centers, right? The world that we're in is where, and this is what I meant by fungible when I said it's fungible, right? That my endpoint, which was a VM on my data center today, or say till noon, might become a VM on an AWS or a GCP or an Azure instance in the afternoon, because that's the most cost-effective way for me to run that application. And what enables that is actually network. And ultimately, if you sort of look at why the concept of Kubernetes has become so popular, because Kubernetes has tried to do the same thing for compute. It allows you to move compute in a very fungible way, irrespective of what the endpoint is. What my vision of networking really is an equivalent for network, where network allows you to fungibly move applications and users as needed, on demand, and very rapidly. Again, coming back to the keyword that you used there.
So I want to build on that, because I think it's a very important concept. And when we talk about static endpoints, look, the performance of every network goes back to Claude Shannon. The performance of every network is a function of the degree of certainty you have in the various parts and elements of the network. Static at one end, static at another end means you can build really, really high performance networks at either end. Uncertain in between means you end up with very, very slow wide area networks.
Yes.
Software defined, however, allows us to bring more information into that equation, so we have better visibility into the patterns, better visibility into the traffic and the routes, so that we can bolster the entire performance of the entire network. Have I got that right?
You got it exactly right. I would go one step further. So there are two camps in networking, and I think both are wrong. One camp is, it's going to remain in physical network because they are most performant and they give you reliability. The other camp is, you don't need physical network, everything is an overlay. And I think both are wrong for the following reason. The best distributed systems are built in a way where you apply the right resource that is most cost effective for what you're doing.
Sure.
So there are resources that are static. Your data center, your number of data centers don't change that rapidly. Where you connect to internet providers or other carriers, they don't change rapidly, right? So the best way of building that is by building physical network with physical routers that does physical packet processing or physical optical gear and so on, because that's the most cost-effective way of moving bits, data, right?
And the number of options that you have to worry about in the future is limited.
Absolutely, exactly, right? But when you are trying to go and tie up endpoints where the endpoints go up and down on demand, a physical network cannot do it. It is just not possible for you to run around the data center and add switches because you decided to have 10% more load on a certain cluster, right? So it has to be virtual. But the key here is that you really cannot have physical and virtual looked at independently, because then they're ships in the night.
That's exactly what I mean. So the whole notion is to uplift the entire, software defined can allow us to uplift the performance of the entire thing, because it is an end-to-end problem. And optimize performance at one endpoint, optimize performance at another endpoint, but not have to pay the performance penalty because we don't have visibility into what's happening in between.
That is correct, and use, whether it's a physical network that is forwarding your packets or it's a virtual network that's forwarding your packet, that should really be based on intent, right? It should be based on, same thing where I'm doing overlay on a switch, let's say I'm doing a VXLAN overlay on a switch in a physical data center, can be applied to a virtual instance that I'm running on AWS using the same VXLAN abstraction, but now it's not a physical switch anymore. It's a function that I'm offering, right? And then that's key.
So CIOs have to, they're not trying to build the new AWS, they're trying to take advantage of this notion of scale computing, any service, any data, anywhere, anytime, anybody, in the context of their business. So how are you, with Juniper, taking a lot of these concepts, which are still need to be diffused in the industry, and turning that into offers, engagement, new ways of doing things that allow these CIOs to start to envision how these principles get applied concretely, discreetly, cost effectively to their business? I was fortunate in having the ability to run a very large cloud network for a long time. That would be Google.
That would be Google, yes. I spent a lot of time with Juniper CIO, because Juniper runs a pretty large IT, right? And one of the things that I hear from him is something that I hear with every single CIO conversation that I have. People have gone into cloud, public cloud, with the expectation of saving money. For most companies, public cloud consumption has been through a shadow IT, where some team decided, my application just seems to run better in AWS. Same thing with Juniper, by the way. And I'm just going to run it there. And when the CIOs start looking at the collective bill that comes from all these cloud consumptions, what they realize is that it's actually not a decrease in OpEx, it's an increase in OpEx. Because instead of running one infrastructure, you're now running 2 or 3 or 4. There is also a myth that there is one public cloud. There isn't one public cloud. There is no standard that defines what a public cloud is. And so, depending on who you're using, you are really building both expertise on your team as well as applications that are specific to that infrastructure, right? And
worse, there are economic powers at play that are likely to avoid coming up with that one standard.
Absolutely, right? And end of the day, if I'm a CIO, what I really want is I have the ability to choose between the options that I have that is most economical for me, but it meets my SLA. Right? That's what I'm looking for, right? And so what I want is one cloud, but not in the way one cloud is described. It's not one cloud from one provider. It's a cloud infrastructure that looks like one cloud to me, so I can use it fungibly, right? That, I believe, is the most critical problem in IT in the last 2 decades.
And isn't it interesting that people continue to think about the idea of virtualizing things, and the cloud is at bottom predicated on the notion of virtualizing, but we still look at the cloud almost as a physical thing.
Yeah.
And what you're really describing is no, you need to take that notion, that concept of virtualizing, and extend it to your cloud utilization as well.
Absolutely.
And it's a network that's going to make that real.
Absolutely. And so what we have been building in Juniper, there were some pretty interesting assets that Juniper had much before I joined Juniper. Juniper acquired a company called Contrail before. Juniper has invested a lot of energy in taking all the routing and the firewall stack and completely virtualizing it so that you can take an SRX firewall and you can run it on AWS the same way you would run on a data center, or take our MX router and run it as VMX or as a gateway for cloud. And then Contrail, which originated in really telco and FVI, has one of the most performant SDN stack that is out there. What we did is we took this asset and we're really delivering on the promise of physical and virtual are the same. So Contrail has been expanded to support obviously the virtual network, which is the SDN that it does, but it now incorporates physical switches and router from Juniper and from our competition. And the second part is important because if I'm a CIO, I don't want to run a cloud that is Juniper cloud and a cloud that is somebody else's switches and routers. It's fundamentally different philosophy from what many of our competition does. And we believe very strongly, I believe very strongly in that philosophy, that if you're really going to take a legacy infrastructure and move it forward to what is truly cloud, you've got to bring the legacy with you. And if that legacy is not Juniper, it still needs to be supported in the virtualization that we're talking about, right? We are heavily investing into integrating not only the capability that we build for OpenStack, which was VM based and physical servers, extending to VMware on one side, but also building the most performant Kubernetes networking that is out there. And I can tell you that we probably have the most performant Kubernetes networking that you not only can run on-prem, which we do with our partnership with Red Hat, but you can also extend the same Kubernetes implementation to all the major public clouds. And what that allows you to do is all of a sudden you have a network that spans physical and virtual. You have the ability to extend the same overlay from your on-prem data center to any of the public cloud ones that you care about. You are able to spin up workload, whether they're VM or whether they're microservices, and use the power of OpenStack or Kubernetes to move it around fungibly in where you need. But the most important bit in all of that is if you're a CIO, what you're most concerned about when you go to public cloud is security. Because when you ran everything in your data center, you have a pretty good idea of where things reside. So whether you have done perimeter security or whether you've done zero trust or a combination, you know what you have. When you're going into an API-based model or serverless, or you are turning off VMs on public cloud, the concept of localization goes away. So what we're really delivering is network not only gives you connectivity, it gives you secure connectivity. So we actually have built extensive distributed firewall in our Contrail product and leveraging SRX. So irrespective of where you're running your workload, you get the same policy, you get the same security implementation, you get the same visibility, right?
And very importantly, it's because certainly the public cloud suppliers have a lot of security.
Sure.
So you can have security here and you can have security there, and you're right, you don't have the same visibility into their security. But even if you had the same visibility, you still have to connect the two together.
Absolutely.
And it's the end-to-end that you're worried about. It's the security in flight.
Yes, absolutely. And it's the same concept of there isn't one cloud, right? So when you describe the same thing.
The cloud's defined by the workload.
Exactly, right? And ultimately, your security needs to be a description of what the workloads can do.
Right.
Not what API I go and trigger.
And where it needs to do it.
Absolutely. Yes.
All right. So this has been a great conversation. I'll give you one last opportunity to kind of say, okay, so where's this end up in 3 years? You're a CTO, you got to worry about this. Help a CIO understand, let's not say 3 years, let's say 5 years, a little bit longer. How is what they're doing right now going to make life better in 5 years, given where the new classes of services are coming from, et cetera? What do you think?
I believe it's a journey, and it's important to acknowledge that it's a journey. So different CIOs are in different places of this transformation. I believe in 5 years, you are going to see a world that is multi-cloud, where every CIO is consuming more than one public cloud, but they're also operating private cloud in true sense, in the definition that I used. And for CIOs, every investment that they make now is going to determine whether they end up in a cul-de-sac where they're stuck with what they know how to operate today, or whether they're taking the steps towards the endpoint, which is a multi-cloud that they can operate in a lot more fungible way. That's the product that we're building, and our goal is to be there when you're ready to take the step. And one of the beautiful thing of the Juniper product family is that you are actually not committing to just buying Juniper products, because it is multi-vendor from day one. It's multi-cloud from day one. It also doesn't lock you into just building things on-prem. You actually have the ability to go on-prem and off-prem. So use that flexibility and make decisions, build decisions so that it gets you closer to the end goal that you have, not where you are comfortable today.
Well, Juniper, by virtue of the situation that Juniper's always been in, has always been a company that focused on connecting, integrating, and cohabitating with other technologies. And it sounds like that remains a core feature of your DNA.
That remains absolutely core.
Bikash Koley, CTO of Juniper, thanks once again for being on theCUBE.
Thank you very much, Peter.
And once again, I want to thank all our audience for participating in this great conversation. Until we have another opportunity to have a CUBE conversation, thank you very much. Great interview with one of the tech industry's true thought leaders. Thank you, Bikash. Okay, now it's your turn. Please join me and others in a crowd chat to explore these myths and truths of data center design. This is your opportunity to engage your peers and other thought leaders to get your questions answered, raise the challenges you'd like to see addressed, and proffer your insights into evolving digital business opportunities. Let's crowd chat.